Hello everyone, I hope you are doing well. So in today's video, I'm actually going to go through the 2021 Maths Methods Exam 2 for the Northern Hemisphere. Extended response questions, yeah, so let's get ready. So let's do question 1. So let f be all reals, so f of x is this function and g of x is this. State the period and the amplitude of g. Okay, that's easy. Your amplitude is equal to 2 and your period is 2 pi. Very nice. Find the value of c for which f of c equals 0, where c is between 0 to pi over 2. Okay, first, let's define all the functions in our cast. So, okay, so f of x is, negative cos 2x plus cos 4x. Plus cos 4x. Yep. And g of x is 2 cos of x. Okay. And we want to find, this. So we want to find solve f of c equals 0 for c given that c is 0 not equal pi over 2. Okay. That gives us c equals pi over 6. Very nice. So c, pi on 6. Next question. Find a minimum value. Very easy. So of f. So what we're going to do is go on menu, calculus, minimum. And we're going to write f of x, x, let's say from 0 to maybe 2 pi to be safe. And we get these values. Just pick one. So f of, let's say 0, and that gives you negative 2 is your minimum. So your min is negative 2. Okay, go down. Next question. Parts of the graph of the functions f and g are shown below. The graph of f and g touch, but do not cross at the points p, q, pi over 3v. Find the values of p and q. Okay. So, because they're symmetrical, you can see that they're symmetrical, your p-value must be negative pi on 3. And your q must be, so at, what's the most basic function? G of x. So, we know g of x. What is g pi on 3? What's g on pi on 3? So g pi on 3, that gives you 1. So, your v... So it means your v value and your q value must equal 1. Yeah, so that's that. Very nice and easy. Find the value of the derivative of f and the value of the derivative of g at this. Okay, so we want to find f dash of x and g dash of x. Okay, so go on your calculator. So shift minus of x for f of x first. And it gives you this function here. So that'll be 2 sine 4x plus sine 2x. Yep. And we want to find f dash at pi on 3. That will give us, so this pi on 3, so x equals pi on 3. It gives us negative root 3. Okay. So find the value of the derivative and the value of the derivative at g. Wait, find the value of the derivative of f and the value of the derivative. Yep, so the derivative of g is now g of x, negative 2 sine x. And g dash pi on 3. Alright, so put pi on 3 in this. Negative root 3. So, okay, both have the same. Find the equation of the tangent to the graph of f and g at x equals pi on 3. Okay. So, tangent at, so f tangent, let's say f tangent is y equals, let's find out. So, menu, calculus, tangent line of f of x, x, pi on 3. it's this here. So it'll be negative root 3 x plus 3 plus root 3 pi on 3. Okay. Yep. And your g tangent is y equals what? So copy that and just put g. And it gives you this over here. It's actually the same. So negative root 3 x plus 3 plus root 3 pi on 3. Okay, nice. Find the equation of the line perpendicular to the graph of f and g. So the same thing. So f normal now of y equals and g normal of y equals. So menu calculus normal line of f of x, comma, pi on 3 gives you this here. So that's root 3 x all over 3 minus pi root 3 minus 9 over 9. And copy that and write now g. It gives you the same. Yep, so it's the same thing. Okay, nice. The area bounded by the graph of f and g is shaded in the diagram below. Okay, find the area of the shaded region. So g is this over here. It's the function that's on top and the bottom one's f. So, well, we can say this. What's the actual, let's say we find this whole area over this whole area, which is the value from this over here to this. So what are those values about? So where g crosses the x-axis. So okay, let's go on calculator and say solve g of x equals 0, comma x. And we get this. Okay. And let's say it's between negative pi to pi. So negative pi x to pi. And we get this. Okay, so pi over 2 and negative pi over 2. So we can say negative pi over 2, which is the starting point, to pi over 2 of g of x dx is equal to what? So that's going to be this. If we take this, put it over here, this, put it over here, g of x dx, that's 4. Okay, now we know that's 4, so now let's find the area of this thing over here. So we can find the area of negative pi over 2 to this over here, this point where f of x touches. So let's solve f of x equals 0, comma x from this over here, the same domain. And what does it say over here? Okay, this is not supposed to be that. It's supposed to be given. And we get this, but it's negative pi. This is what we want. These are your values. So to negative pi on 6, we run our calculator. So to negative pi on 6, this area, and then we multiply by 2. So what we're saying is, so negative pi over 6 f of x dx, and then we multiply by 2. So what is the integral? What is the integral from negative pi over 2, put it to here, negative pi on 6 f of x dx, and we get root 3 this, and what can we do with that? So it means that we now know this over here. So we now know this, and we can pretty much minus it from this. So for minus this over here, which we have this. So what we have now is we've minus this, and now f of x. So we want to find also f of x from 0 to, from negative pi on 6 to pi on 6, f of x negative f of x dx. So let's solve that too. So negative, am I overdoing it? I think if it's that much marks, or am I overlooking at it? Let's just try to finish this. So f of x dx, and we get this. Whoa. Wait. These are the same values. Does that mean, wait, okay, let's come back here. Okay. Wait, it means, let's rub this all off. It means this here, the area, is the same as this area over here. So, wouldn't it just be 4? Wouldn't it just be 4? Because, no, you know what, I was going to take the area of the whole thing, but they've minus this, but it's still added again back here, so it's just 4. Yeah, so yeah, that was such a tricky, I don't know if it's tricky, but yeah, 4. Question 2. So the function h of x is this, where x is from 0 to 50, models the rate at which heat is lost from water in a hot water pipe with insulation, where h of x is the rate at which the units of heat are lost from the water, and x is the radius. So x is the radius of hot water pipe with its insulation. Okay, so this is your x right over here in millimeters. The diagram below shows a cross-section of the pipe with its insulation. The radius of the pipe without its insulation is this. So without insulation, okay, is this. The graph of the rate of the heat loss from the water over the time is given here. Okay, find the rate at which heat is lost from the water in a pipe with no insulation. Okay, we know when no insulation occurs is at 10. So it means that this over here is like 10, if I'm not mistaken. When there's no insulation, so your value 10. So we're saying h on 10 is what? Okay, let's define the function on our calculator. So control N this. And at calculator, so your h of x is 3 x minus 5, and we square it, times the natural log of x minus 5 over 4. Okay, so we have this, and we're trying to find h of 10, which is 28 point, so correct the 3 decimal places is 28.562. State the derivative of h of x, so h dash of x is equal to what? So that's easy. So shift minus and put h of x in the function, which is this. So let's write that. So negative 3, 200, 2 log e x minus 5 minus 4 log e 2 minus 1 all over x minus 5 to the power of 3. Find a maximum rate at which heat is lost from the water. Correct to 3 decimal places. So maximum rate, this is easy. So it's only 1 mark. So I'm just going to go on menu, and I'm going to go on calculus maximum h of x, comma x, given that we know it's from 10 to 50. Okay, we have this. So now we shove it into a function. This value over here. It gives us this. To 3 decimal places, that's 36.788. A particularly insulated pipe has the same rate of heat lost from the water as a pipe with no insulation. Find the thickness of the insulation for this pipe. So find the thickness of the insulation. So we want to find this thickness over here, this thickness. So we'll calculate the whole thing and we'll minus. So we'll calculate this whole thing over here, and then we'll minus 10, because we know this is 10. We'll minus, and it'll give us this over here. That's what we want. So we can say, what do we know? Well, we know that a particularly insulated pipe has the same rate of heat loss with no insulation. So we know no insulation is at 10. And we know h of x. So if we solve this, so solve h of x equals h on 10, comma x, we get these two values. Now, this value here, we must minus it by 10. Gives us this over here. So that is your thickness. So your thickness is equal to, in 3 decimal places, so that's 5.288, yeah, millimeters. If both the radius of the pipe were without insulation and the radius of the pipe with insulation, wait, this is so confused, wait, if both the radius of the pipe were without insulation, so no insulation, that's 10, and the radius of the pipe with insulation, as shown in the diagram of page 14, are doubled, show that the rate of heat lost from the water H1 is given by this equation. Okay. So if both the radius of the pipe is doubled, so would that mean, so if both the radius of the pipe without insulation and the radius of the pipe with insulation, so there's a dilation happening here. Yeah, there's a dilation. So because it is on the radius of the pipe, which is your x here, this over here, which is over this value here, this x over here, there is a dilation by a factor of half. A dilation by a factor of 2, because we're doubling it, parallel to the x-axis, meaning that your h, so h1 of x is equal to h, so we would dilate it by, so to write that will be x over 2. And that would mean that h over 2 is what? So, wait, so, okay. We know that, let's double check it. So h, x over 2. Okay, is that the same? Looks like it. Yeah, so it looks the same. So let's just show some working out. H x over 2 is what? So we know. Okay, so if we sub in, so that's 2000 over here. Let me say h over 2. Oh, actually x over 2. Let's say x over 2. X over 2 minus 5 squared log e x over 2 minus 5 over 4. Okay. It means that x minus 10 over 2 squared log e x minus 10 over 2 all over 4 through 200 will be multiplied by 4, and this will be x minus 10 squared and log e, so divided by 4, x minus 10, 8. So right. So yeah, whatever I did here, I'm just going to copy and paste it really. X minus 8 is that, 10 is this. So I'm just going to copy this. I'm going to come back over here, paste it over here. Okay, write it nicely. So x minus 5 all over 2. Wait, that's supposed to be 4 here. Okay, something like, yep, so that, and it's been simplified, which is, I can copy this whole thing, make it smaller, put it over here, and say, which would equal 1 to 800 all over x minus 10 squared. I'm going to take this actually, just like this. Log e x minus 10 over 8, and that's that. So that's h1 of x. And your domain is, because it's just dilated by a factor of it's dilated by a factor of 2 parallel to x, so everything doubles. So it means your radius, your actual domain doubles. So your dom of h1 is, what was it again? This is 10 to 50, so it'll be 20 to 100. 20, 100. Yeah. Describe the transformation that transforms the graph of h to the graph of h1. Easy. So it is a dilation by a factor of 2 parallel to the y-axis. Oh, no, x-axis, parallel to the x-axis. Or you can also say, there's another way you can say it, you can say dilation by a factor of 2 from the y-axis. Also is the right answer too. So yeah, both are right. Find the area between the graph of h1 and the horizontal axis over its domain. Give your answer to this. Okay, so what we're saying is, yeah, so we know that's 20, that's 100, h1 of x dx, which is what? Wait, find the area between the graph and the horizontal. Yeah, so just find out. So, integral of 20 to 200, or 100, sorry, 100 of this function over here, dx, that's 1079 to 3 decimal places, it's 171. Yep, units squared. Let the area found in part EI, so this one over here, be A. Determine the area between the graph of H and the horizontal axis over the domain in terms of A. Yeah, so that's very easy. Your area, your new area, let's say area 1, it's just 1 over 2. It's half of it. Determine the area between the graph of H, because the area will half. Determine the area between the graph of H and the horizontal. Yeah, it makes sense. This over here was like this. But what we've done is we've dilated everything by a factor of 2. It means everything's doubled. Your y value's doubled. So it's just going to be looking... It's pretty much... The area doubled. Another way, the area actually just doubled. So to get it back to the original, we'll half it. So area must be half. Yeah. Question 3. The parabola arc of a tunnel is modeled by the function negative. So this, where a must be less than 0, and b is an element of all rails, and c must be greater than 0. Okay. Let's be the horizontal distance in meters from the origin, and let y be the vertical distance. Okay, so in meters above the base of the arc. The graph of f is shown where the coordinates of the y-intercept are 0 to k. So yep, 0 to k, and the coordinates of the x-intercepts are these. Okay. Express a and b in terms of c and k. Okay. Well, we know that f of 0 must equal k. So that means that b must equal k. That's easy. And also, we also know that, well, for our a, we also know, let's say we choose this point, which is c0. So if we sub in that in, so we're saying 0 equals a c squared plus b. We know b is k, so So it'll be negative k ac squared. So negative k c squared equals a. So these are your both answers. So a equals negative k over c squared, and b is equal to k. These are your two. A particular tunnel has an arc modeled by F. So it has a height of 6 meters. So your k value here is 6 meters. Yep. And at the center, yep. And a width of 8 meters at the base. 8 meters. So width is 8 meters. So this whole thing is 8. So your C value is 4 for this one. So state the rule. Okay, this is nice. So we know that it's written as A. So what's A? Negative K. We know it's negative K. So it's negative K C squared. Okay, C squared. Okay, C squared X squared plus B. X squared. But B is plus K. So anyway, plus K. Plus K. So knowing that, and so your height is 6, so negative 6 over 4 squared, 16, x squared plus 6. So your new rule, let's say f of x is equal to, that'll be half, so negative 3 over 8 x squared plus 6, is that right? I think so. Yep, so it's a parabola, 6 units, like that. Okay, nice. So it looks, yeah, looks promising. So in this, a truck has a height of 3.7. So this truck's height, so okay, and a width of 2.7 will fit through the arc with the function this. Okay, assuming that the truck drives through the middle of the arc, let d be the minimum distance between the arc and the top corner of the truck. Find d and the value of x for which this occurs. Okay, so this point here is what? It's pretty much, we know it's okay, so it says a truck has a height of this. So this is its height. So, and a width of this. So dividing that width, 2.7 divided by, so 2.7 divided by 2 is 1.35. So 1.35, 3.7. Okay. Now we know this. And let's say this point here is x, and the y value is just negative 3, 8x squared plus 6. So your distance can be written as the square root of negative 3, 8x squared plus 6 minus 3.7 squared plus, okay, x minus 1.35 squared. 6. Okay, let's do this on CAS. Okay, so what we're saying is your distance, so d equals the square root of negative 3 x squared over 8 plus 6 minus 3.7 squared plus x minus 1.35 squared. And it gives us this ugly function. So now what we're going to do is menu and go on. Okay, first let's actually find the derivative of it. So because we want to get, it's 3 marks and we need to show working out. So let's say distance is d of x. D of x, so d dash of x is, so shift minus x, this whole thing over here is this. So let's write that. So root 5 45 x cubed minus 11 6x minus 216 all over 20 square root 45x power 4 minus 232x squared minus 864x plus 2276. So that. And we want d dash x equals 0. So x must be some value. So to do that, I'm just going to quickly go on calculus minimum value of this over here. Over here, comma, x, comma. Where is x between? Well, it must be between 0 and your c value, which was, what was our c value for original? Wait. Our c value is, it must be between somewhere. So it's 3.7, let's say it's 4. Your minimum value, control enter, is 2.18 blah blah blah. So this 2.1 to 3 decimal places. So 2.185. And it means that D 2.185 is equal to, so what is it, distance right over here, enter. So your x over here is 0.978. Yeah, so that's your answer. Okay. Those are your answers. Okay, so these are your answers. Okay. A different tunnel has a semicircle arc. The arc can be modeled by the function from -6 g of x. Okay, so this is a semicircle formula. R is greater than 0. State the rule of R. Very easy. R is your radius, so and our radius is 6. So R, 6. Is that right? Yeah. R must be greater than 0. Okay. 2 lights have been placed on the arc of a arc 2 lights, the entrance of the tunnel. So these are 2 lights, and they're putting some light. The positions of the lights are this and this. The area that is lit by this area is shaded in the diagram. Determine the proportion of cross-section of the tunnel entrance that is lit by the light. Give your answer as a percentage to the nearest integer. So first, let's just find the whole area of the whole tunnel. Let's try to find the whole area here. So it is what? Well, it is very easy to do that because area of a normal circle is 2 pi r. It's actually pi r squared. What am I doing? It's pi r squared. But it's half of it, so half pi r squared. Pi r squared, so let's write AT. So AT equals 1 over 2 pi. So 6 squared is 36. So AT is 18 pi. That's your total area. How can we find the area here? Okay, not too bad. So let's say if we find this area of this whole triangle, it means that we need to find this height here, which is not too bad because it's just 5. And we double it because it's the same as this over here. It's the same as this. But the problem is it will give us an extra area of this. So, but we want to minus this. So we'll find the area also of this. And we want to minus it. So we want to minus this over here. So let's try to do that. So it's going to be so let's say area of that triangle is area of the triangle. So just draw area of the triangle is, there's triangle 1, is half your base, which is 12. Your height is 5, and we're multiplying by 2, so it'll just be 2. So it'll be just 12 times 5, which is 60. Okay, now we need to find the area of so we need to find the area of that red triangle. So triangle 2 is half, your base is still 12, but that height here is what? So to find that height, I am just going, because I know this gradient over here. I know that gradient, which is 5 minus 0 over root 11 minus 6, so plus 6. So that's your gradient. So it will be y minus 5 equals 5 over root 11 plus 6 x minus root 11. Okay, so y equals 5 root 11 plus 6 x minus 5 root 11 over root 11 plus 6 plus 5. So this over here is your y-intercept here. So putting that here, we get area equals, let's do on a cast, so it'll be 6 times negative 5 root 11 plus 6 plus 5. Control enter, we get 19 this, so that. Okay, so we have this, and it means we say 60 minus this over here, let's just put it nice, is equal to this number, 40, this, blah, blah, blah. So now we have this, 40 this, divided by 18 pi on, so 18 pi, which is this. Oh my god, 18 pi then, how? What have I done here? Alright, just let's quickly really do this again. So I know that it's 60. Let me just do this by calculator then. This whole calculation by calculator. So your area of squares is what? So it's going to be what? So we know it's so the gradient is 5 minus 0. 5 minus 0 and root 11 minus, so minus, so plus 6, which is a positive gradient, yes. So y minus 5 equals this x minus root 11. So we get this. So we solve answer, comma y. We get this. So this is your y-intercept. So we can say half 12 this over here, which gives you this 19.32. So 60 minus that. So 60 minus that. And we get 19.32. And this, we want to divide it by 18 pi on 3. 18 pi. And this, okay. What's happening here? Am I making a full-on mistake here? Wait. Okay. What am I making here? What am I doing that's wrong? Okay, let's just double check something. So this here is so this. Let me get this. So this is supposed to be a y-axis. Is this that? So 3.2 looks right. So if this is that, and we're saying that 0.5 times 12 times that height, this height over here, and we're getting this area. So wait, so we have this. Yes, and we 60 minus that, yeah. 60 minus that gives you this. Ah, what the hell's happening? I see it's 60 minus this is this. How? So 60 minus your answer. How does it give me this? 60. I see, it's my calculator. So 60 minus this. It's 40.67. Okay. So 40.67 divided by 18 pi. Okay, I'm just going to be honest. So this... Okay. Just trying to think how. So what is 18 pi? 18 pi is 56. Okay, so it's this divided by this, which is this, times it by 100. This, 72. Oh my god, what's this question, bro? So 72% is your proportion to the nearest integer. I'll be honest, this question, I don't know, it's my cat that's effed up. I've been doing this question for so long. 3 marks. Oh. Okay, okay. So, let's say, okay, so this will be like 19.32. And we say 1 minus 8.2, which is 40.679, blah, blah, blah. And then with that, I said 40.679 divided by 18 pi times 100, and it gives me this over here. Yeah, I'm going to move on. That question is a pain. I don't know, it was my cast. It was just, yeah. Question 4. A particular petrol station has 2 air pumps, A, B, to inflate tires. Each inflation of a tire is independent on any other. When pump A is set to 320 pascal, the pressure that the tires will be inflated follows a normal distribution with a mean of this and a standard deviation of this. Find the probability that the tire will be inflated to a pressure that's greater than this. So, probability that the tire is greater than 330 by pump A. Look, I gotta go quick because I took too long on the other question, so Control N, and so add calculator, and we're gonna say menu, probability distribution, normal CDF, 330 to infinity. Okay, your mean value is 320 and 10, and we get 0.1587. The probability that the tire will be inflated. The probability that a tire is inflated by pump A to a pressure greater than A. So X is greater than A is 0.9. So we can say the probability of X is less than A is 0.1. Using menu, probability distribution, inverse norm, area is 0.1. Your mean value is again 320, and your standard deviation is 10. Okay, we get 3. Okay, yeah, looks right. So A must equal 307 to the nearest pascal. Okay, when pump B is set to 320 kilopascals, the pressure that the tires will be inflated is to be modeled by the following probability density function. Okay, determine the mean tire pressure for the tires to be inflated by pump B. So, okay, let's say B of X is defined as 440,000 X minus 310 squared 330 minus X. Okay, so we get this. So the mean is what? So we normally know that the mean, let's just write it down. So your expected value is your from 310 to 330 X B of X dx equals what? So, okay, so, what's happening? Okay, so 310, 330 B of X times X, so X times it, dx. 322. 322. Next question. A randomly selected tire is inflated by pump B. Find the probability that this tire will be inflated to a pressure greater than the mean. So probability x is greater than 322. Pressure of a tire is inflated by pressure. Okay. So we want to find out when it's greater than the mean. Normally it's 0.5, but here we just double check it. So it's 322 to 330, was it? 330. 330 b of x dx. And that gives us 0.5248. Nice. Find the probability that a tire is inflated by pump P to a pressure less than K is this. Okay, so probability that the tire is inflated by pump P to a pressure less than K is 0.95. And we want to find our K value. So this can be written as the integral from K here. K is less than it. So what's our least value? 310. So 310 b of x dx equals 0.95. So your K value must equal, so 310 K b of x, oops, so b of x dx, it must equal 0.95. So solve answer, comma K. And we get K is 328, these two, but this is your answer because the max we can go is 300. And so our domain is from 330. So it can only be this one. So K is equal to the nearest Pascal, let's do 328. A motorist is equally likely to use either pump A or pump B, okay, to inflate one of their car's tires. So find the probability that the motorist has used pump A, so probability that he's used pump A, so X, let's say is, I don't know, like X is, so he's used pump A, so let's say X is A, pump A given that the tire is inflated to a pressure greater than this, so let's just rewrite this whole thing. So pump A, given that we want X to be a pressure that is greater than 325. Find the probability that the motor has a pump A, given that the tire is inflated to a pressure greater than 325. Okay, so this simplifies to what? Probability A intersection X is greater than 325 all over probability of X is greater than 325. Now, remember that A pump B, and they're half because they're equally likely, and this is inflate. So let's say inflate, non-inflate, inflate, non-inflate, non-inflate. Okay, so to get this, it's so it comes from A, and it's halved. So let's look over here. So if we go back up to a question, we're saying menu, probability distributions, normal CDF. If I go back to it, so 3 to 5 to infinity, your mean value is 320. Is that right? So 320. Your mean value is 10. And we half this. Because we half it. Because remember when we try to we're multiplying A and this. So this gives us 0.15426 all over. The probability that X is 325. So we know it's going to be this plus this one over here, which is half times the probability that's from pump B. Now we know pump B is what? It's the integral from 325 to 330 of b of x dx, and we're going to half that value times this, and we get this 0.13, 0.13, blah blah blah. So your answer, your probability of a given x is this 325 is equal to this here divided by, again, this plus this. And that gives you, what the hell is this? Oh, okay, no, I see what I did. Let me write it nicely. So let's just put, okay, this nice, okay. We're saying this right over here. And again, take it again. Plus this. And that gives us 0.541, blah, blah, blah. So, correct in the nearest four decimal place, it's 0.541. A company that manufactures the pump tests all of its pumps and removes that those are defective. The probability that a randomly selected pump is defective for all values of pumps is this. So this is defective. Find the probability that there are 4 pumps, so probability that x equals 4. The pumps from a sample of 25 randomly selected is this. Okay, this is easy. So I'm just going to use my calculator, menu, probability distributions, binomial PDF, number of trials, 25, p 0.08, x4. That gives us this value here. So 0.08 for decimal places, 99. Nice. A random sample of 25 pumps, p this is a random variable that represents the portion of pumps that are defective. Find the probability that p is greater than this. So we want to find the probability that p is greater than 15%, which is 0.15. Well, we know that p hat is what? X over n. So, and our n is 25, so 25 times 0.5. So 0.15 times 25 is what? So 25 times 0.15, that gives us 3.7, which is just 4. Think of it just as whole number 4. So it's the probability that x is greater than 4, which is the same as the probability of x is greater or equal to 3. So find the probability that x is that. Okay, this is not too bad now. So go on menu, probability distributions, binomial CDF, 25 for the probability of success 0.08, lower bound is 3, and the highest bound is 25. So 0.3232. Is that right? I found a proof that is greater than this, correct for decimal places. Yeah, looks right. Let's go to the next question. For a random sample of n pumps, so n we don't know, Pn is a random variable that represents the portion of pumps that are defective for the least value of n such that this. Well, we know that, again, P this is what? X over n. And our P over here is 1 over n. So 1 over n, x over n. So x must equal 1. So this can be written as probability of x must be less than 1 is less than 0.15. Okay. So this is probability of x equals 0 must be less than 0.15. This is quite easy if you just use inverse binomial. So go on your calculator, menu, probability distributions, inverse binomial n. Binomial n. Cumulative probability is 0.15. Probability of success is still 0.08. And success is 0. Enter. 23. Your n is 23. Okay, hopefully this is the last question. Looks like it's the last question because, yeah, I think I'm going too long for this exam. Okay, let's just try to do it quick. Let f of x be this and g of x this. Part of the graphs are shown. find the coordinates of the point of intersection of the graph of f and g labeled as a and b in the diagram. Okay, they're positive because they are on the right of the x-axis. So Control N, and let's go on at calculator, and let's really define the function. So f of x is defined as 1 over 5x squared minus 6 over 5, and g of x as negative 4 x over 5. So we know this. So find the coordinates of a point of intersection. So we want to solve f of x equals g of x comma x, and we get this, but we only want these two because they're two positive. So what's g, this value here, and what's g, this value over here. Okay, so we get these, so let's write them. All right, so we wanted to solve, let's write, because it's 2 marks, so solve f of x equals g of x. So your point of intersection is, the first one is a, is half negative 2 over 5, b root 3 plus 1 over 2, negative 2 root 3 plus 1 over 5. Determine the area bounded by the graph of f and g between a and b. Give your answers to this. So, so your g is the upper function here. So this can be written as half root 3 plus 1 over 2 g of x minus f of x. So yeah, g of x minus f of x dx, which is what? Okay, let's write it. So half is 0.5. Let's take this and put it over here. Move x minus f of x, x. And we get this. So to the nearest, okay, we want it in this form. So let's write it. 3 root 3 over 5 minus 9 over 10. So it'll be 6 root 3 minus 9 over 10. Which is negative 9 plus 6 root 3 all over 10. Yeah, so yep, that's that. So I'm just going to rub this off over here, and I'm just going to put it over there. I'm going to put it over here. Nice. Okay, P is this and Q is this, where A is greater than 1. Find a value of A for which P of x is equal to f of x and Q of x is equal to G of x. Okay, because they're similar, we have A over here. So we have A over here. What's our A there? 5. So 5 plus 1, 6. 6. Yeah, so A equals 5. That'll give a similar. Okay. Find the positive x-intercept of P in terms of A. So I'm going to define those. So it's P of x as defined as 1 over A times x squared minus A plus 1 for A, and Q of x as x times 1 minus A over A. So the positive x-intercept, okay, of P. So solve P of x equals 0, x is this. Because we know A is greater than 1, this will be negative, but we want only this one. So take only this one over here. So x is equal to 1 over root A plus 1. Point M lies on the graph of P of x. The tangent to P at M is parallel to Q. Find x coordinate of M in terms of A. Okay, so the tangent to P. So P dash of x is what? So wait, P dash of Wait, point M lies on the graph of this. The tangent to P at M is parallel to Q. Find x coordinate of this. So, what do we know? So P dash of x is what? So this, what's P dash of x? So, if we go over here and say shift minus x of P of x, we get this. So it's negative 2 ax to the power 3. And let's say P dash is some value like r. That's our x value. So it'll be negative 2 over ar to the power 3. And we know that, let's say P of r must equal to, it's because it's parallel to Q, and Q is this gradient over here, 1 minus a over a. R must equal, because that r is your x coordinate, so r is what? So let's take this. Let's just type it as r equals 1 minus a over a, solve, answer, comma r. And we got r is this, which is your x value. So let's just write it as x. It's much nicer. Yeah, it's much nicer if you write it as x. So x is equal to 2 1/3 all over a minus 1 1/3. Yep, that's your x coordinate. Find the y-intercept of the tangent to P at M. Okay, so very easy. Just, we have it over here. So what we can do is, so find the tangent to, so go menu, probability, no, not probability, calculus, tangent line of P of x, comma x, comma this function over here. And we get this, but we want the y-intercept, so we only want this part. So let's write that. So y equals 3 a minus 1, 2 over 3, multiplied by 2, 1/3, negative 2, a plus 1, all over 2a. So that's your y-intercept. Given that 2x 3 is greater or equal to 2 1/3, x minus 1 2/3 for x is greater than 1, show that the tangent to P, so show that the tangent to P parallel to the Q will have a negative y-intercept for all a's greater than 1. 1 mark. Okay, so we can see that they're similar. So 2 1/3 is over here, looks similar to this. So I'm going to do this. So, all right. I'm going to just change these x values to a. So it looks like 2a over 3 is greater or equal to 2 1/3 a minus 1, 2 over 3. And what do we know? Well, we want to make it to look like this. So how can we do that? Well, we have the a minus 1 2/3. It's multiplied by this. It's all multiplied by 3. So if you multiply both sides by 3, it'll be 2a, 3, and it will look like a minus 1, 2 over 3, multiplied by 2 1/3. So it's looking similar. What else? Let's just expand this. So minus 2a minus 2, minus 2a minus 2a minus 2. So we will also minus 2a from it. So this will be 0. Minus 2. And we also want to minus 2 from it. Minus 2. We want to all divide it by negative 2 over a. So minus 2, 2 over a, greater than, and it'll look like pretty much similar to this. So right over here, if I just copy this, copy and paste over here, make it smaller, it looks like this. So, okay, so it means that negative 1 over a must be greater or equal to that. Okay. So, what does that mean? Negative 1 over, and we know a is greater or equal to 1 over here. So any values you put in a, it will make it negative. So it's proving that it's a negative y-axis. So yeah, that's how you prove it. So can we just say, would you say this? So we can say, I'm going to copy this and paste it over here. Just nicely here. As a is greater than 1. Yep. Negative 1 over a will be greater or equal to this. Okay, what about... Okay, this is not one nice way. What about we just switch them around? So we bring this over here, and we switch the signs and put negative 1 over a. Doesn't that make more sense like this? So we're saying that, yeah, so this y-axis must be less than negative 1 over a. But when a is greater than 0, so we know that a is greater than 1, it's going to pull out negative. So this is smaller than negative, so it has to be a negative number. So as a is greater than y-intercept must be negative or something. Must be negative, yeah. I don't even explain that. Just for a mark, I'll write that. I'm not even, yeah. The tangent to P parallel to Q has a negative y-intercept. So explain why this implies P and Q will always enclose a region bounded by both graphs for A is greater. Wait. Explain why this implies so much writing. Wait. Explain why this implies P and Q will always enclose a region bounded by both graphs as A is greater than 1. The tangent to the parallel to Q has a negative y-intercept. So if I go up and copy this picture, just as a reference, nice reference. So if I take this and copy, okay, go down. Let's use this to answer this question. So, looking at this, what can we see? Let's say this is M, right over here. And it's like a tangent to it. So we can see it's a negative. So it has a negative thing. So if it was not negative, think of it like this. If this part was not negative, it will be like, so the tangent to P parallel to Q has a negative 1. So explain why this implies P and Q will always enclose a region by the both. Yeah, so if it has a negative, it means you can see that it will always enclose. Like, if you go down, still encloses. You can still see that it encloses. Is that maybe A is greater than 0? Or, because if there's a positive y-intercept, then it's something else. Oh my god, this is so confusing. Wait. One mark. The tangent to P parallel to Q has a negative y-intercept. Okay, yes, so negative y-intercept. Explain why this implies that P and Q will always enclose a region bounded by both graphs for all A is greater than 1. For all A is greater than 1. So we know that here, the A must be negative. So if we move this, so let's just say, okay, I'm just going to give the basic. I'm looking at the graph, yes, that for it to actually be enclosed, it must be a negative y-intercept. So I'm just going to say, I'm just going to push this over here and put it right over here and say, explain why this implies P will always create as, but in this term, this is what's this? This is Q and this is M, and this function is P. So we can say, as Q of X is at the origin, the tangent of P at M must have a negative y-intercept for an enclosed region, to be bounded by both graphs. Okay, so I think I understand. Now, wait. I think I fully understand. So this, say if there's a tangent here, we can see it's bounded, and it's always negative. So in any way, it's like, imagine like this. Like if I maybe rub this off and make it more easier. So like, say we had a point over here. We just draw a tangent. Still negative, and still bounded. What about over here? Hell no, that's not negative. That's a positive. This one over here is positive, but it does not bound it. Yeah. I'll be honest. Yeah, that's a confusing. I don't know. Especially it's such a last question. I'm just gonna rush this. I think that is probably the wrong answer, but I'm not fully understanding. Explain why this implies P and Q will always enclose a region bounded by both graphs. Bounded by both graphs. Okay. Yeah. Skip that one now. That's the last question. Part of the graphs of Pn shown where A is 100. Show the area bounded by the graph of P and Q. So find the smallest B. So find the smallest value B such that the shaded area, this area, is less than B for A is greater or equal to 100. Where A is greater than equal to 100. So we can read that as like B must be greater than A. So so the area increases. So this is like, what is the max? Like it will hit the max. Your B value is your max. So to do this, I think I'm just gonna graph it because I feel like this one would be easy if you do it on the graph. Okay, so go on and so write both equations. So P of X and Q of X. Yep, so Q of X. Okay, so, and they're saying A must be greater or equal to 100. So let's say this is 1,000 and this is 100. Okay, and let's look at this here. So what can we see? If I look over here, let's zoom in. Okay. And go on menu, actions, pointer. Okay, so let's look at this. As we increase, it's getting more and more like a triangle. To be sure, I'm going to put another 1,000 here. So we put, so it's getting closer to a triangle, but we know it never approaches it. So that's why so your B value is that triangle. It's like the actual area of that triangle. And we know that, so your B value is the area of the triangle because it's greater than A. Our area will never approach that triangle in the long term. So B is half. What's your base? Well, let's say we increase this, and let's say we find this base over here. So intersection of these two is negative. So that's 1, -1. So it's just 1, 1, half. So your B value is half. Yeah, that was a right question. I hope you guys enjoyed this video. I'll be honest, I'm not too sure for this question over here. I have to check the answers and have a look at them. I hope most of these are right, to be honest, because yeah, I'll be honest, this exam was alright. It's not too bad. It has a lot of worded questions. I don't like worded questions, especially. This question especially, I am not too sure also. So I need to double check this one too, because this one, I think I got so many different answers. So I got to double check that one. And yeah, so all the other questions were alright. And yeah, hope you guys enjoyed this video. Make sure to like and subscribe, and please share this video with your friends. If you want more videos like this, I'll be doing more physics, chemistry, specialist maths and methods in the long term. So yeah, please subscribe so you can be up to date. And I hope you guys enjoyed this video. Have a good day.